So that's what we're looking at here. We're looking at GDP for all these different countries. And let's say I want to compare like how Brazil is doing over time or who's doing better out of Germany or France. This is just the raw data the student sent me. What do you think I said to him? Because there is a bit of a problem in terms of using what we've got here effectively. Gave him a bit of a chat. And I was like, as diplomatically, I was like, it's not really suitable in the present form. It's not something technical, guys. It's just really annoying. Well done, Rishab. I mean, look, it's just so hard to read what's going on here because we're looking at this is pretty much going to be hundreds of billions or trillions. That's the kind of size of the numbers we're looking at. And if I said like roughly what percent did France grow between 2005 and 2006, if I just like extend the number out, like I doubt there's anyone amongst us who can easily, look at that and go, oh well, that's like that's about 3%, 3% increase, maybe a few of you. But whatever. So the problem is with a lot of economic data is we're dealing with really, really large numbers. This is the kind of raw data we might get. And we wanna transform this. We want to change it so that it's sort of easier to understand, easier to read, easier to show what's going on. And that's where index numbers come in. Okay, index numbers is just a way to effectively transform a data set or change a data set to make it easier to understand and easier to read. And you can do this with any numerical data. It doesn't have to be economics. It could be your height over time. But you might say, like, why would you index your height over time? Because it's pretty easy to understand height. It's not like really big numbers or anything. So you kind of see like why you might use indices or indexing in some sort of situations and why you might not in others. But all right, what I'd like you guys to do is pick a couple of countries you are interested in, and we'll have a look at indexing their GDP data. So just put answers in the chat. The first two in the chat, first come, first serve. Those are the ones we're doing. If anyone's doing like a geography project on, I don't know, France, now's your time to get a small benefit. Oh, Christian says China, I don't know. Well, there we go. That is a good one. Why is China a good one? Because we will find out later when we talk about GDP and who is the richest country in the world. So, China, a very, very interesting one to do. On this project in general, actually, one of the sort of key themes is the way China is kind of an exception amongst these developing countries in how much it's grown. They've all grown, but China's sort of a whole new level. So let's just take this down. And what we're going to do here is we'll make a China index. So our study or the research I'm helping with is looking at 2000 to 2020. So sorry, 2001 to 2020. So I'm going to take the year 2001 and I'm going to make this the base year or the base value. And anyone know what you do with the base value? Very, very simple. 100, good, yes. So the base value, you just always give that 100, and yeah, that's going to be used to compare against other values. So we're just going to give that a value of 100, and it's arbitrary. So it doesn't matter. Like any year could be the base value. There's no like way you select the base year. In this case, because our study looks at the change from 2001 to 2020, it does make sense for us to use 2001 as the base year because we can compare different points in the study to the start. But again, you can pick any year as 100. So, okay. And what I want you guys to think about is, let me move this down. Mathematically, how could I get from the number above to 100? How can you go from any number to 100? Oh, I can't get control of this. So how can you turn any number into 100? What's like a mathematical operation there? It's really simple. Divide by what? divide by itself times 100. Excellent. So if we basically divide this number by itself, divide our base and times 100, that operation will give us the index number for every value. It's that simple. So I'll sort of demonstrate that here. Let's copy this 2001 value. So let's say our index equals this value, F6, divided by itself. Put that in brackets because I forgot whether I need brackets or not for this. So let's just be safe. So that times 100. Oh my goodness, what have I done there? Oh, of course. Sorry, guys. Times. There we go. So that's the equation to convert this value here, the 2001 GDP, into the number 100, divided by itself times 100. So let's pick a figure like 2006, which, just eyeballing it, we take 2001. Oh, sorry, guys. Take 2001, put that in bold, just so it's easier to see. And then we take 2006. Just eyeballing it, 2006 looks like it's about twice as big as 2001, right? So if the index for 2001 is 100, and we know the GDP for 2006 is twice as big, what should we expect the index for 2001 to be? Sorry, for 2006. We know the index for 2001 is 100. 2006 is twice as big. Yes, exactly. 200 is what we should expect. So let's just see if that equation holds true by taking it across. There we go. So our index for 2006 is 205, which is telling us that the GDP in 2006 was about twice as big, an extra 105% to be specific. So you can see that the actual like maths to create an index for China's GDP here is really easy. Is really easy. There's very few steps involved, and hopefully you can see the benefit as well. It's easier to kind of see that's a 105% increase from 2001 to 2006, looking at the index as it is to look at the raw data. So, and again, like we can see 2002 is 9.8% bigger. GDP grew by 9.8%, which is a lot between 2001 and 2002. So again, much easier to use the index we've created. And you can, again, I'm gonna post this data set in the stream afterwards. I really encourage you guys to pick a country, make an index, check each other's work, see if there's differences. I know that's effort, but you'll familiarize yourself with it, and if you spot like a mistake in someone else's work or they spot a mistake in your work, it's pretty easy to sort of work your way around it. So all we've done is we've basically pick a base, and remember to get the base value to 100, you just divide by itself and then times by 100. And then to convert everything else, you also just divide by the base and times by 100. So basically, I'll put this on the board actually. So basically, if we want to put it as an equation to convert any set of numbers to index numbers, first pick a base. You can't do this unless you pick the base. And then you just take value you want to index. There is a better way to write that, but I'm just going to focus on clarity here. Value you want to index, divide it by the base value, not 100, the actual raw data. Jay has just joined us. All right, and then just multiply by 100. So you can do that for any data set, and that will give you a set of index numbers for that data set. So that's the basics. That's the basics. Okay. Any questions on that before I sort of barrel on? Okay, I'm going to assume no. So just some important tips then. Now, we really, again, we're a little constrained by time. It'd be lovely to go through loads of examples. The main reason I'm saying like have a look at this yourself is because we don't have time to sort of really hem it home. But I'll just give you guys some key tips for working with index numbers then. So you can see the percentage difference. Let's just wait. There we go. So you can see the percentage difference between the GDP values fairly easily. So 2002 is 10% more than 2001. 2003 is 24% more than 2001. 2004 is 46% more than 2001. However, you cannot do this between two non-base numbers. So it is not true. And that again, in terms of like key notes from what I'm telling you today, that is really key point for index numbers. You cannot calculate the percentage change between non-base numbers through subtraction. Because that's what we're normally doing, right? We just subtract, we say, okay, 110 minus 100, that's 10, that's the percentage change. 146 minus 100, that's 46, that's the percentage change. So between the base and any other number, we can calculate the percentage difference through subtraction. Simple. Between two non-base numbers, you cannot do this. To save time, I'm not going to go into why. If you're really into your maths, you probably know why. You'll be able to work out why pretty quickly. But again, to save time, I'm just gonna give you that as a fact, as a rule to remember. It is not a 14% change between 2002 and 2003. If you calculate the percentage change, you'll prove it. That is not a 14% increase. I think it's going to be more like 12 or 13% increase. So in fact, let's just prove it now. Very nice and easy. So difference over old, 124 minus 110, that's obviously 14, over old over 110 equals 0.1272 multiplied by 100. So we end up with 12.7%. Okay, so 110 to 124 is not 14%, it's 12.7%. A lot of the multiple choice questions they do on index numbers, a lot of the traps will often revolve around this, trying to lure students into that mistake of subtracting to get the difference at the percentage change between two non-base numbers. So, okay, the second key point I would give when it comes to using base numbers, like the key tip, something in the chat, well done, yep. So if we get rid of the raw data for China, so I'm just gonna cut. Oh no, that doesn't delete. Oh no, then the index goes, of course, hide. Yes. It's been a while, guys. I've been having a very relaxing summer. Got to get with the program a little. So okay, so we've just got the China index. We don't have the raw GDP data anymore. What I want you guys to tell me, answers in the chat, is what information is now hidden? What information can we still perceive? What can we still take away from this index set we've got here? What information have we lost? What information have we retained? Hopefully what we've lost should be pretty simple, but maybe what we've retained might be a little bit more difficult. Devian says we've lost GDP data, but we've retained info about growth. You are, I think, right in what you're saying, but could you be more specific? Drew says change in value as a percentage, change in value and good, right? So I think Drew has got it. Vinesh, great answer as well. Rishabh, yes, well done. The value has been indexed, and Niati, well done. So what the index shows us by itself is the change. It doesn't show us the actual raw data, right? We've completely lost the raw data, as Drew said. We've lost the monetary value. But again, remember this could be used for anything. It doesn't have to be like a monetary thing. It could be used for your height, whatever it's being used for. The index does not show the raw data, and the reason I say that's a key tip is that's the second way they try and trap you on index number multiple choice questions. So the first key tip and the way they'll try and trap you is that you cannot calculate the percentage difference between two non-base numbers through subtraction. You have to use the percentage change equation. And secondly, they'll try and trap you by they'll give you a multiple choice question with index numbers, and one of the answers will sound right, but it's about the raw value, and you've been given index numbers, and the answer will be like the raw value of this is increased relative to another country, and to spot that that's a trap, you've got to remember index numbers, you lose the actual value. You don't know what the value was. We don't know whether this was 2 trillion, 3 trillion, 12 trillion. We just don't know. But we do know what the trend, what the change was in China's GDP. So I think that's a very, very useful tip with index numbers as well.